All right, so for this lesson, we are on 1.3, and we are going to measure segments. So we're going to find the lengths of segments and compare the lengths of different segments. So I'm going to start off with a postulate, and this postulate is called the ruler postulate, and it states that every point on a line can be paired with a real number. That makes a one-to-one correspondence between the points on the line and the real numbers. The real number that corresponds to a point is called the coordinate of the point. So when we look at a number line, like in example 1, we look at segment ST. The coordinate of S is 4, negative 4. The coordinate of T is 8. So if we want to find the length of ST, we have to figure out the distance between S and T. And there's a lot of different ways to do that. A simple way to do it would be to subtract the two values for the coordinates. So that means ST is 12. Some of these you can use mental math, others you may want to use a calculator, but it's a fairly simple process. You are subtracting the values of the coordinates to find the length of a segment. The next postulate we talk about is postulate 1.6, the segment addition postulate. And it states that if 3 points, A, B, and C, are collinear, and B is between A and C, that means that segment AB, the length of segment AB, plus the length of segment BC equals the length of segment AC. So we're going to use equations to help us solve problems that involve adding segments together. So example 2 involves some algebra and the segment addition postulate. And it says, if EG is 59, what are the lengths of EF and FG? So this is understanding that F is between E and G. So that means that EF plus FG equals EG. Okay? And I'm going to erase that, but I want us to understand that EF plus FG equals EG. And we have all the measurements we need to set up an equation to represent this situation. So the equation I'm going to set up is EF, which is 8x minus 14, plus FG, 4x plus 1, equals EG, or 59. I've got my equation set up. I added the two segments together, set it equal to the entire segment, and now I just simplify and solve. 8x plus 4x, like terms, that's 12x. Negative 14 and 1 are like terms, it's negative 13. And it's a fairly simple process to solve that equation. We've done this before. 12x equals 72. X ends up being 6, which is great. But I didn't ask for what x is. I asked for what EF and FG are. So to find EF, I substitute 6 for x. So that becomes 48 minus 14. EF is 34. FG, 4 times 6 plus 1 equals 25. And this should make sense because 34 plus 25 ends up being 59. So it's understanding the equation we have to set up and the values we have to find. We may have to substitute back in to find those values. For the guided practice, you can work on this on your own and check your answers on my completed notes in Classroom. So moving on to example 3, comparing two segment lengths. I've used this phrase before, but congruent means, for segments, means segments that are the same length. Length. So if I'm looking at AC, I can determine the length of AC by seeing that A is negative 2, C is 5. Okay? So I take 5 minus negative 2, which is 7. Okay? 5 minus negative 2 is 7. BD, the length of BD, B is 3, D is 10. So those coordinates are 7 units apart. these segments are the same length, so I would say yes, they are congruent. That's enough for you to say they are congruent. They are the same length, okay? So, moving ahead, again, this guided practice, I would like you to work through it and check your answers using my completed notes in Classroom, all right? I'm going to move on to the last examples that include midpoints. So the midpoint of a segment is a point. A midpoint is a point, that makes sense, that divides two segments into two congruent segments. Okay, it's the middle, all right? A different definition, a point, line, ray, or other segment intersects the segment at its midpoint. We say that bisects the segment. So you're going to have to know what bisect means. That point, line, ray, or segment is called a segment bisector. So a segment bisector is a little more broad because it can be different figures. A midpoint has to be a point. A bisector could be a bunch of different things. A bisector could be a point, line, ray, or another segment. So it's just understanding what a bisector does. Cuts a line in half into two equal parts, two congruent parts. So in example 4, using the midpoint, it says that Q is the midpoint of PR. I want to find the lengths of all three segments. If this is the midpoint, if Q is the midpoint, what that means is segment PQ and segment QR are congruent. And from what we talked about before, congruent means they are the same length. If they are the same length, these two expressions have equal values. If these expressions have equal values, I can set these expressions equal to each other in an equation. And this is only true if this is the midpoint, all right? Splits that into two equal parts. So for me to solve this equation, I would subtract 5x from both sides. So I get x minus 7 equals 1. Add 7 to both sides. X is 8. So for my answer, I really have 3 pieces I need to find. Oops, PR. I need to substitute into each, expression and then find out the entire length of the segment. And I'm going to use some critical thinking to figure out what's what here. So, knowing that x is 8, I can find PQ by taking 6 times 8 minus 7, which is 48 minus 1. PQ is 41. I don't need to do much else to figure out what QR is. If I know that PQ is 41, I know that QR is 41 because those segments are congruent. They're the same length. And I can go back to that segment addition postulate to say that PQ plus QR equals PR. So 41 plus 41 is 82. So initially, I had to substitute 8 in for x, but using my knowledge of midpoint and segment addition, I can figure out the other lengths of the segments in the diagram. So that completes example 4. This guided practice again. You can work through it, check your answers using my completed notes, and then you should be ready for the practice and eventually the checkpoint.